Curious about the Windows Subsystem for Linux, or WSL? In this video, I'll give a beginner-friendly breakdown of WSL1, the first version, and WSL2, the second version, of the Windows Subsystem for Linux. You'll discover how WSL lets you run Linux on Windows and explore the pros and cons of each version.
3, 4, 5, 6, 7, 8, 9, 0, 2, 5, 7.
What is WSL? Well, I mentioned earlier that it's the Windows Subsystem for Linux. What does that really mean? It's a compatibility layer developed by Microsoft to run Linux binaries on Windows. There are two flavors. There's WSL1, that's the original, which runs without a full Linux kernel, and it translates Linux subsystem calls into Windows systems calls, and thus allowing those Linux applications to run directly on the Windows kernel. Then there's the second version called WSL2, which runs a real Linux kernel in a lightweight virtual machine, allowing Linux applications to run directly on its own Linux kernel. They have their own pros and cons for each, but remember, they can be used at the same time, which is a nice benefit. Since WSL1 came out first, I'll go ahead and touch on that one first. It's got some distinctive advantages that I want to touch on. For WSL1, when you're accessing the Windows file system directly, inside those Linux distros, you're going to be able to see the Windows drives as they are. And this is going to provide fast file I/O performance for cross-system operations when we compare that to the WSL2 virtualized file system. WSL1 uses fewer system resources than WSL2, since there's no virtual machine kernel or overhead from a CPU or RAM perspective. That's going to make it leaner and able to run more simple workloads better. It's also going to make it a little worse for complex workloads, but we'll get into that soon. WSL1 allows seamless interoperability, letting you run Windows commands from Linux and Linux commands from Windows. It does have some limitations, though. WSL1 only supports a subset of the Linux system calls. It's sufficient for most command line tools, scripts, utilities. However, it lacks support for some of the more advanced features, like certain kernel modules, C groups, or specific networking capabilities. Some Linux applications like Docker, a variety of different databases, or any tools requiring specific kernel features have a chance to fail or require workarounds due to missing system calls or those kernel modules that we keep talking about. WSL1 lacks support for GPU acceleration, USB devices, or other hardware integrations. While file access to Windows is fast, Linux-specific file operations, such as those you would find on an ext4-like system, are less optimized and will run less quickly. Well, if WSL has so many limitations and there's a newer version out, why would we want to use WSL1? Well, if you need fast access to Windows files from Linux, you're going to have a better chance in WSL1 hitting those performance needs. If you're running lightweight Linux tools, Git, vim, maybe even basic shell scripts, those aren't going to require advanced kernel features. If your workload doesn't require Docker, GPU support, or other hardware support, or you're not utilizing complex Linux applications, still might be a good choice to use WSL1. With WSL1 wrapped up, let's move on to the second version, WSL2. It has a real Linux kernel, which provides better compatibility with Linux applications, tools, and system calls. This makes it ideal for running software that requires kernel modules. You can see that in Docker, Kubernetes, or other complex Linux environments that WSL1 has a tendency to struggle with. WSL2 offers several advantages depending upon your use case. You can have faster CPU and memory performance for most workloads due to its virtualized architecture. It's particularly beneficial for compute-intensive tasks like compiling code, running simulations, or using development tools. WSL2 supports Docker desktop natively without requiring workarounds, as it can run containered and other container runtimes that rely on the Linux kernel features. This is a major advantage for developers working with microservices or other containerized applications. WSL2 uses a virtualized ext4 file system, which provides better compatibility with Linux native file operations and tools. While accessing Windows files is slower than in WSL1, Linux file operations within the WSL2 file system are significantly faster. WSL2 supports GPU acceleration for CUDA or DirectX, making it suitable for machine learning, data science, or other graphics-intensive workloads. It also supports USB devices and other hardware integrations, which we mentioned WSL1 lacks those hardware integrations. WSL2's full Linux kernel reduces compatibility issues with Linux software that relies on specific kernel features, making it a better choice for running modern Linux applications or development environments. For long-term support, Microsoft is focusing development on WSL2 with new features like systemd support, GUI app integration via WSLG, and improved network being exclusive to WSL2. There are some trade-offs to consider when we use WSL2. We mentioned earlier that file access, Windows file access from WSL2 is slower, and that might impact workflows that rely heavily on cross-file system operations. Despite being optimized and a lightweight virtual machine, WSL2 still runs a VM, which consumes more memory and CPU processing power than WSL1. WSL2 virtualized networking may require additional configuration changes for some applications, which can be a bit of a hassle. If you are already using WSL1, you might want to consider switching over to WSL2 if you happen to find out that you need Docker or Kubernetes support or other container tools. If you're going to start utilizing GPU accelerated or hardware dependent applications, run complex Linux software, of course, WSL1 is less likely to be able to handle those. If you want faster Linux file system performance staying inside the Linux environment, or you need better overall compatibility across applications in the Linux environment. To bring it all together, if your workflow is simple and relies heavily on the Windows file system access, or maybe you're already working just fine in WSL1, there's no need to change. WSL1 is probably going to work for you just fine. If you have more complex or modern Linux workloads, WSL2 is likely going to be a better place to start or migrate to. If you're not sure and this hasn't helped you yet, don't forget that you can still run WSL1 and WSL2 side by side and test out your use case, your applications, and see which one works best for your situation. If you've made it this far, I really appreciate you sticking around and learning with me as we talk about the Windows Subsystem for Linux. If you have enjoyed the content, please do hit that like and subscribe button. It really does help the channel grow.